Hi guys, welcome back to Mathematics 0110. This lesson is on functions. Before going into the properties of functions, I want to review the notation of functions. And you can think of a function as a type of machine. You put something into the machine and something comes out. So if a function is a function of x, x is the quantity that goes into the machine. And we often say that a y value comes out. So x values go in, y values come out. In this example, we're given a function, f of x is 3x squared minus 4x, and asked to plug some x values into it. The first x value is 2. The notation for plugging x equals 2 into this function is f of 2. We're replacing x with a number that we're putting into it. That means we're going to replace x everywhere in the expression with 2. So 3 times 2 squared minus 4 times 2. You have to be careful with order of operations. The exponentiation is done before the multiplication, so 3 times 4. And the multiplication is done before the subtraction, so 4 times 2, 8. We have 12 minus 8, which is 4. Okay, we'll do the next one. F of negative 1, so that'll be 3 times negative 1 squared minus 4 times negative 1. Something squared means we're taking it and multiplying it by itself. So negative 1 times negative 1 is positive 1. So 3 times positive 1. And then we have minus 4 times minus 1. That'll be positive 4. A negative times a negative is a positive. 3 times 1 is 3. So we have 3 plus 4, which is 7. And then the last one tells us to plug 0 in. So 3 times 0 squared minus 4 times 0. 0 squared is 0. So 3 times 0 minus, and then 4 times 0 is 0. So we have 3 times 0, which is 0, 0 minus 0, which is 0. And that's okay, we'll have to get 0 out of a function. So here's a picture that just reinforces the machine aspect of a function. You can imagine that x is being plugged in like a coin into a pop machine, and a can of pop comes out. The function in the bottom picture, x to the power of 3, it's taking the inputs, in this case 0, 1, 2, and 3, and giving the outputs 0, 1, 8, and 27. Each of those outputs coming from taking the inputs and cubing them, raising them to the power of 3. So to evaluate a function, we just go through the steps that we did in the first example. We plug a number into it. So here's another function. We're asked to evaluate this function at 2. So f of 2 is going to be 5 plus 3 times 2 squared, which is 5 plus 3 times 4. Again, being careful with our order of operations. 5 plus 12, so 17. Here's a word problem that's essentially a question about function evaluation. A manufacturer can speed up the production of light bulbs at the expense of introducing defects. So they run the equipment quicker, more of what's being produced is going to be produced in a less useful way. It's just going to come out defective. It's going to come out so they can't use it, they can't sell it. The number of defective bulbs produced per hour as a function of production speed x has been modeled. So someone has obtained data and created a model that best describes the defective bulb rate as f of x is 50x plus 20x squared. So taking this model, part A says how many defective bulbs will be produced at a typical production speed, which corresponds to x equals 5. So that's part A. Let's answer that by plugging 5 in. If f of x tells us how many bulbs are being produced at a speed of x, then f of 5 tells us how many defective bulbs are being produced at a speed of 5. So f of 5 equals 50 times 5 plus 20 times 5 squared, which is 250. Since 50 is 5 times 10, we do 5 times 5 first, 25, and then times the 10, 250, plus 20 times 5 squared, so 20 times 25. So 250 plus Well, 20 times 25 is 2 times 25 times 10. 2 times 25 is 500. There's 50 times 10 is 500. So we have 250 plus 500, which is 750 defective bulbs are going to be produced per hour at that speed. So that's the regular rate. Okay, part B asks us what happens if we double the speed, if we go up to a speed of 10, and whatever those units are. So f of 10, let's see, we get 50 times 10 plus 20 times 10 squared. So 500 plus 10 squared is 100. 100 times 20 is 2,000. So 2,500. In doubling the speed, we have more than doubled the number of defective light bulbs. Double of 750 is 1,500. We have 2,500. The reason why doubling the speed has more than doubled the number of defective light bulbs is that our function is a quadratic. It goes up faster than a linear function. Right, and here's some examples I've been given in previous years' tests. The first one's too easy. F of a, find f of a for f of x is equal to x squared plus 1. So this machine, instead of putting 5 into the machine, you're putting a into the machine. So the x gets replaced by an a. Our answer is just a squared plus 1 instead of x squared plus 1. The next one's more complicated. We're replacing x not by a, but we are replacing it by a plus h. So let's write that out more carefully. F of a plus h is, now if it was f of 5, we would have 5 squared plus 1. F of a is a squared plus 1. Well, what's f of a plus h? It's a plus h squared plus 1. Notice that's not an option. You might be tempted to circle C. It's wrong. Let's do FOIL. Let's do it carefully. A plus h times a plus h plus 1. We do FOIL first times first, so a times a squared. Outside times outside, a times h, plus another a times h for inside times inside, plus last times last, h times h squared, and then the 1 is still hanging out. Now we can collect like terms. The a squared does not combine with anything, but the a times h and the other a times h are like terms. We can combine them. It's two of those things, so 2ah. The h squared is not common with anything. There's only one of those, and then a plus 1. And that answer is there. It's option B, but just the order is different, the order of addition. And changing the order in which you add things does not change the answer, so it's safe to circle B. Domain is an issue or a concept that causes a lot of confusion. And one of the reasons it causes confusion is that to solve a domain question is not often a type of problem that you follow a recipe for. It's a type of problem where you try different things, where you think about, you have to attack in different ways. Well, what is domain, first of all? Domain describes the x values that you are allowed to plug into a function. If this function was a pop machine, the allowed things we can put into the pop machine would be coins and maybe cash, but not rocks or shoes or hats. If there's things you can put into a pop machine and there's things that you can't. There's things you can put to a function and there's things that you can't. So you'd say, well, okay, it's just numbers, right? I have to put a number into a function. Well, no, look at the last example. We put a into a function. So, and not only that, but sometimes some numbers won't work. You might put a number in and the machine will break because it just can't accept that number. Part of the problem with domain is that it violates some language that you would have come across previously. You would have learned previously that we call x the independent variable and we call y the dependent variable. So that seems to imply, x being independent, that we can pick anything we want for. The truth is that we can't. X is a number that we choose, y is a number that comes out, but we don't have complete freedom to choose any x value that we want. It does depend on the precise form of the function. So you can think of domain as a type of restriction. How am I restrained in my selection of x values that I can plug into the function? There are a multitude of ways that you can break functions. If inverse trigonometric functions or log functions. There's going to be additional ways that we can break those. But in this course, at this point, we will only have two problems to worry about as far as domain is concerned. We can break a function if we plug a negative number into a square root, or into a fourth root, or into any even root, because you can't take the even root of a negative number. The other issue that we have to watch for is division by zero. Division by zero is undefined. So 5 divided by 0 is undefined, 2 divided by 0 is undefined, and 0 divided by 0 is either undefined or indeterminate, depending on the language that you want to use. We're going to use indeterminate in this course, but for the sake of domain, it would not, a number that caused that to happen, 0 over 0, would not be included in the domain. So let's use those two rules to answer the domain question for these two problems. In part A, we're asked for the domain of f of x is the root of x minus 5. And we're thinking, how do we prevent negative square roots? So no negative square root. So what we want is we want x minus 5 to not be negative. So that means x minus 5 must be greater than or equal to 0. It can be 0. We're allowed to take the square root of 0. Square root of 0 is 0. But it can't be negative 1 or negative 2 or anything else like that. The domain is a request to get a restriction on the x value. Right now we have a statement that says x minus 5 must be greater than or equal to 0. We can get a statement that has x all by itself by manipulating the inequality. Inequalities can be treated in some ways like equal signs, in some ways not like equal signs. For example, we can add numbers across each side of an inequality. In this case, it's helpful to add 5 to both sides, so that's what I'm going to do. I'm going to add 5 to the left-hand side, so plus 5 minus 5, that's going to cancel. I add 5 to the right-hand side, 0 plus 5 is 5. And that's my domain. All x greater than or equal to 5. That's one way to write the answer. Or we could write x inside the interval 5, recalling from week 1, if we want our interval to include the endpoint, we put a square bracket, and as high as we want, because it's as long as it's larger than 5, we're good to go. So 5 to infinity with a round bracket, because by convention we put round brackets around infinity, because infinity is not really a number. Or I shouldn't say not really a number, it's just not a number, period. So that's two different ways that we could write the domain, one with inequalities and one with brackets. Second question here, different function, different problem. In the first question, the problem was the square root, because we cannot take the square root of a negative number. In this problem, we don't have a square root, but we do have a division. And what we have to worry about is division by 0. So we want no division by 0. So we want x squared minus 9 not equal to 0. When is x squared minus 9 equal to 0? So x cannot equal 3, and x cannot equal negative 3. We could write, or x does not equal to plus or minus 3 to contain both solutions in one statement. It can't be positive or negative 3. Both of those would cause the denominator of that function to go to 0. Or we could use the bracket notation. Bracket notation is tricky. We want all the numbers on the number line except those two. So that means we can go as negative as we want. So I'm going to start at negative infinity. And then we have to stop when we hit negative 3, because negative 3 is not included. To indicate that's not included, I'm going to put a round bracket. This means negative 4 is included, negative 5 is included, negative 3.0001 is included, but negative 3 itself is not. We also have the numbers that are, let's say, negative 2, negative 1, 0, 1, 2. We have those numbers. They begin as soon as we pass negative 3, like at negative 2.9. So I'm going to go round bracket negative 3, and then we keep counting up until we hit positive 3, that next forbidden number. Now put a round bracket around that to indicate that positive 3 is not included. I can get as close to it as I want, but I can't actually include it. And then I can continue as we get to numbers larger than 3. So 3.1, 3.001, 3.001. I'm just going to put 3 with a round bracket around it to indicate that I can get as close to 3 as I want, but a little bit larger. And then we end at infinity. So these are the 3 sets of numbers, and to join them I use the union symbol to indicate that the answer is all the numbers that are indicated there, which just cuts out positive 3 and negative 3. So those are 3 different notations for the same answer. Here's another question. What is the domain of this function? X over the square root of x plus 2. And it's multiple choice. I'm going to answer this question the same way, and notice in the first one, it was kind of boring. The numerator was just 1. And in this one, the numerator is x. You might be worried, well, do I have to worry about that? Does that get involved? But well, all we need to prevent is no roots of negatives and no division by 0. So no square root of negative, no division by 0. So this first restriction, no square roots of negatives, means that x plus 2 must be greater than or equal to 0. That'll prevent the square root of a negative number. And not dividing by 0 means x plus 2 cannot equal 0. We need to combine both of those restrictions. So I'm going to combine them by saying that x plus 2 must be strictly greater than 0. I'm going to get rid of the equal sign underneath the inequality. Okay, now I'm going to add 2 to, or subtract 2 from both sides, so x must be greater than negative 2. So any number larger than negative 2 is part of the domain of this function. Like, for example, x equals negative 1. I plug that in, I get negative 1 on top, negative 1 plus 2, so positive 1 down below, negative 1 divided by the square root of positive 1, so negative 1 divided by 1. That exists. It's an answer. It's a number. 0 is also an answer. I get 0 divided by the square root of 2, so 0 divided by almost anything is 0. The exception being 0. You can't divide 0 by 0. Other than that, you can divide by anything you want. You'll get 0. And then 3 is an answer, and 4 is an answer, and so on. We have to convert into the bracket notation. So x is greater than negative 2, so we're starting at negative 2 with round brackets to indicate that negative 2 is not included because we don't have the equal sign underneath the inequality, to infinity. So that would be option B. And we'll stop here for video 1 and continue in the next video.